going to start by reviewing how to convert from time domain expressions over into the phasor domain. We'll start with a simple circuit that consists of a voltage source, 100 times the cosine of 500t plus 30 degrees. We're going to apply that voltage to a resistor, 100 ohms, an inductor, 0.3 henries, and a capacitor, 40 microfarads. We'll start our shift to the phasor domain by converting our voltage source to its phasor equivalent, picking off the amplitude and the phase, and rewriting them as a polar form complex number, 100 at angle 30. The impedance of the resistor, Z sub R, is just 100 ohms, purely real. The impedance of the inductor, on the other hand, is a function of the angular frequency. J, square root of minus 1, times omega, times the inductance. J, the angular frequency for our voltage source, is 500 radians per second, times 0.3 henries, for a grand total of J 150, and it's ohms now. The impedance of the capacitor is also a function of the angular frequency. 1 over J omega C minus J times 1 over omega C, which is minus J times 1 over 500 times 40 times 10 to the minus 6 for a grand total then of minus J 50, and that is also ohms. Just like we had when we were working with resistances back in chapter 2, we will have a series equivalent impedance, that is the sum of the impedance of the resistor, the impedance of the inductor, and the impedance of the capacitor. 100 ohms plus J 150 ohms minus J 50 ohms for a net impedance of 100 plus J 100 ohms. This consists of a real part, the resistance, 100, and the reactive part, also 100. If we think about these three impedances on the complex plane, the resistor is purely real. It has a length of 100. The inductor is purely imaginary. It has a length of 150 in the plus J direction. The capacitor is also purely imaginary. It has a length of 50 and it points in the minus J direction. And that's all you need to know about converting from time domain to the phasor domain.